This is topic 4.1, interpreting the derivative in context. So basically, we'll recall the concept of slope. And the slope between 2 points we've learned is the change in y over the change in x. Or try to think about this, the change in the dependent variable divided by the change in the independent variable. It's important because we look at the units of each one of those. So you could think of the derivative of f of x is whatever this unit of f is going to be divided by the unit of your x. What's your independent variable? I'll put f of x here. So it is definitely something we need to be aware of for our units, okay? We'll work some examples here. One other concept I really need to make sure you understand is that if the derivative is positive, then f of x is increasing. And that kind of makes sense because let's just say the slope of that tangent line, that's the derivative, is positive. That's where the curve is increasing, okay? And if the first derivative is negative, less than 0, then f of x is decreasing at that location. And you might find the slope of the tangent line right here to be negative, so that is where that curve is decreasing. So not, something we probably already know, but I just, wanted to make sure that we covered that. Okay, now let's go ahead and take a look at this first example. Mr. Sullivan wants Mr. Brust to finish creating his packets in Algebra 2. The number of packets Mr. Brust has completed is modeled by P of W. Now, W is measured in weeks, okay? And the number of packets is P, okay? So now let's go ahead and take a look. What does P of 10 equal 1 mean? Okay, so basically P of 10, we have to take that 10, that's our W. So after 10 weeks, Mr. Brust has completed 1 packet. So that's pretty straightforward. But what if we took the derivative of P? Remember, it's a rate. So we still want to look at our x value of 39. Whoops, I wanted to make that yellow. And change that to yellow. Those are our x values, and those are the weeks, okay? So on the 39th week, or in week 39, on the 39th week, Mr. Brust is making packets here comes the rate, at a rate of 4 packets per week. So it's really, really important. And one of the most important things you can remember is this at a rate of. You really want to use that at a rate of, okay? In fact, I could go ahead and take this off, and then I'm going to highlight that in green, and that way you will know that that is so important. So at a rate of is talking about the derivative. Okay, when we take the derivative, we're finding a rate. Okay, let's look at this last example. And the rate at which Mr. Kelly is buying baseball cards per year is modeled by B of T. So now T is measured in years. So T is years. And of course, B is the rate. So this is the rate at which he is buying. The buying rate is B of T. So we are starting with a rate. So B of 3 equals 150 means on the third year, and again, this is years, Mr. Kelly is buying cards at a rate of 150 cards per year. So we started with a rate, but now we're going to take the derivative of the rate, okay? So B prime of 4, again, 4 is going to be our T measured in years. So on the fourth year, now let's think about this. The rate at which Mr. Kelly is buying baseball cards, whoops, so it's a rate of buying, is increasing. Now it's increasing because that's positive at a rate of 10 cards. Now think about this. Per year. Okay? We were per year before we took the derivative. So now we're per year. Okay? Or you could leave the units as 10 cards per year squared, if you'd like. So that concludes this topic.